So yeah, let's talk about exponents. So this is, I think, an operation that you kind of take for granted quite often. When you first learn about exponents, kind of think of them as just like, how many times are you multiplying this certain number, right? Like if you say like 2 cubed, hopefully you think about like 2 times 2 times 2, right? You're multiplying 2 by itself that many times, and more or less that's how exponentiation works. It does get a little weird when you start raising something to like negative exponents or fractional exponents, because it doesn't really make sense anymore to say, oh yeah, multiply 2 by itself -5 times. Like, what does that even mean, right? We'll get into that. And also, like, what does it mean to multiply 2 by itself a half of a time? Like if it was like 2 to the 1/2 power. Then that sort of classic idea of exponentiation starts to fall apart a little bit. But we can still try to make sense of it. And I'll hopefully by the end of today, you'll understand all that. But today we're really just going to focus on, how to write expressions using exponents. We really have a better idea of, what it means to raise something to a power. And then we'll get into exponential functions next time. Okay, so when you see something raised to a power, like x to the first, x to the second, what you should be thinking about is you're multiplying that base that many times. Okay, the number that is like underneath the exponent, like this x, right here, that's called the base. This is the base of the base. I can't spell it. This is the base of the power. And then the actual exponent is that number in that little superscript position. Okay, this is what we call the exponent. Now, you typically, if you're thinking about like 2 cubed being 2 times 2 times 2, there's nothing wrong with that. But I want you to start thinking about these powers as terms with a coefficient. Okay, meaning like there's some number in front of the x to the power. So that number out in the front, which most of the time you won't see, but sometimes it'll be there, that's called a coefficient. And this will make more sense as we move forward, but when you think about this repeated multiplication, if you don't see a coefficient out to the front, I want you to assume it to be 1, so that when you're thinking about like what this actually means, x to the first power, I want you to think about it as like 1x to the first power. In other words, like 1 times x, which seems a little redundant. Like, why not just have x? But if you're thinking in terms of like, I'm multiplying x this many times, multiplying something by itself one time, that doesn't really make sense with that definition. So instead, I want you to be thinking about it as like you're multiplying this base by the coefficient this many times. So 1 times 1x, x squared, I want you to think about that as 1 times x cubed. You're multiplying 3 x's, but you're still multiplying it by that coefficient. Now, it might seem kind of weird, why are we throwing in that extra times 1? But as we move forward and start talking about negative and even fractional exponents, it'll make a lot more sense why we're including that coefficient in there. Okay, so I don't want to get into any of that yet. Let's just make sure we understand this notation. Okay, so 3x to the fourth, what does that really mean? It means 3 times x times x times x times x. In other words, you're multiplying 4 x's. Okay? As opposed to if we wanted to simplify 4 times x times x times x times x, that would be 4. And then we've got 1, 2, 3, 4 x's, so 4x to the fourth power. So you can either expand the expression or you can simplify it depending on what it is you're trying to do with it. 2x to the fifth would be 2 times 5 x's. if I have x time, 10 times, let's see, 1, 2, 3, 4, 5, 6, we got 7 x's here. All right, there's 7 of them. We can rewrite that a little bit more efficiently as 10x to the 7th power. 5x to the 6th is 5 times x times x times x, 6 is here. Whereas here, that's a lot of x's after that 12. Just be careful counting them. When it gets to be like more than like 6 or 7 or whatever, sometimes I find it useful to underline them as you count them so you don't like double count an x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 12x to the 11th power. Three y cubed is 3 times y times y times y. And sometimes if you have multiple variables, like in this last one, it's got some x's, some y's, you can't combine them. Don't think of them as like terms. You can't put them together. You're going to leave them separate and just count them separately. So here we've got 1, 2, 3 x's. So x cubed times y to the 5th power. All right. So a lot of this is just sort of definition so far. Where we want to go with this is I want you to be able to manipulate expressions that have exponents. So we're going to get into like how do you multiply these terms? How do you divide them? How do you add them and subtract them? So with multiplication, what you want to do is multiply the coefficients, and you're going to multiply the coefficients, but you're going to add the exponents. Okay? If it's easy to forget, it can be easy to forget that rule. So if you're like unsure how to combine these, one thing you can do is expand everything, regroup all the like terms, and then put them all back together. And you will end up with what we're sort of expecting here, which is 10x to the 5th. But here's how that sort of plays out. Is if I expand this, I have 5 times x times x times x, right? So 3 x's, times 2 times x times x. Once I regroup it and put those exponents, or the coefficients together, so 5 times 2, and I put the x's together, it's a little easier to see why we're multiplying the coefficients. 5 times 2 is 10, and adding the exponents. Because the exponents represent how many times you're multiplying the x's. So here I'm multiplying the x 3 times, and then an extra 2 times. Meaning like we're multiplying x a total of 5 times. But we can take that shortcut, multiplying the coefficients and adding the exponents. And I really want to encourage you to use and abuse that shortcut. So let's see if we can we can simplify some of these using that shortcut. So again, we're going to multiply the coefficients. Okay, you're going to add the exponents. Okay, and just as a little disclaimer here, add the exponents for like variables only. Like don't combine x's and y's. So like variables only. Okay, so number 1, x to the 5th times x to the 3rd. We don't see a coefficient on there, so we're going to assume those to be 1. 1 times 1 is 1. We're going to multiply those together, and then we add the exponents. We're multiplying 5 x's and then another 3 x's, so 5 and 3 make 8. So we don't really need that 1 there. We can just write this as x to the 8th. For the next one, we've got a coefficient of 2, a coefficient of 1. 2 times 1 is 2. And then we can add the exponents together. 4 and 2 make 6. With number 3, 3 times 4 is 12. Now we're multiplying 2 x's and an additional 3 x's, meaning we're multiplying a total of 5 x's. 2 plus 3 is 5. So x to the 5th. Now you could do this with more than just 2 terms. Like on number 4, we see we got 4 terms, but we're still going to approach it the same way. We're going to multiply all the coefficients. So like 2 times 1 times 3 times 4. So we'll do that. And then we can add all the exponents. And one thing to be careful here is if you have an x that does not have an exponent, that exponent is assumed to be 1. So let's go with the coefficients first. 2 times 1 is 2. Times 3 is 6. Times 4 is 24. And now we'll add up all the x's that we're multiplying here. Again, don't forget that if you don't have an exponent on an x, then it's assumed to be 1. You're just multiplying 1x. So 4, and then an extra 1 is 5, and then 2 more is 7. So x to the 7th. That exponent is just keeping track of how many x's are being multiplied. Now number 5, see x and y, those are different variables. So you cannot combine this. This is already simplified. There's nothing we could do here. If there was, maybe if there were different coefficients, we could multiply them together. We'll see that in the next one. But 1 times 1 is just 1 anyway, so it's just x to the 4th y squared. Not really anything we could do with that. Number 6. Oh, yeah, yes, ma'am. Oh, yeah, of course. Number 6, we've got 5 times 6. We can multiply those coefficients. That's going to be 30. But as far as the variables, since these variables are not the same, we don't want to combine them. We're not keeping track of like how many variables are being multiplied. We're keeping track of how many each one. So there are 2 x's and 6 y's being multiplied. So even though we couldn't combine the exponents, you can still combine the coefficients. All right, any questions so far? All right, let's move on. Yeah. So that's how you multiply, but how do you divide? Okay, I'm going to show you one where we can really break it down, but I also want you to know the shortcuts. Okay. So let's work this out by expansion first, just so you can kind of see where the shortcut rule is coming from, and then we'll just kind of cut to the chase here. So first, if we expand this expression, 10x cubed over 2x to the 6th, that'd be 10 times x times x times x over 2 times x times x times x. There'd be 6 x's here. As far as regrouping, there's not really like a lot to regroup here unless you have different variables, or if maybe if you had like 10x cubed times 2x cubed or whatever. But what I do like to do is kind of separate out the coefficients. So I can treat that as like its own little fraction and simplify that separately. So I'm going to have 10 over 2 times x times x times x over, and then we've got 6 x's. Okay, so now is where we're going to simplify. Okay, 10 divided by 2 is 5. And then as far as the x's are concerned, anything divided by itself is 1. So x over x is 1. So for each pair of x's that you have here, you can reduce that to a 1. And you can effectively just cancel them out. So we can reduce that to 1, reduce that to 1, reduce that to 1. And so we're left with just 1 over 3 x's. Okay, if you cancel out everything on either side, either the top or the bottom, you're still going to be left with that 1. So 5 times 1 is 5, and then x times x times x is x cubed, and so we get 5 over x cubed. Now, this is something we're going to elaborate on next time, but I want you to look at this shortcut here that we might be able to take advantage of. Notice that we ended up with 5, which is really just 10 over 2. Right? You can divide the coefficients, and then, although this is going to look kind of weird now, it'll make a lot more sense next time. You can actually subtract the exponents. 3 minus 6 is negative 3. And so we're dividing by x cubed. There is a connection there that we'll, like I said, we'll elaborate on that next time. But with division, sometimes it's better just to be careful here before we start taking advantage of all the shortcuts here. All right, so let's just go through a few here, and then I've got some practice problems for you guys to work on. Okay, so number 1 is x to the 5th divided by x squared. So if I expand that, I get x times x times x times x times x over x times x. And I can cancel out pairs of x's because x divided by x is 1. So like these will reduce to 1, these will reduce to 1. And that just leaves me with x times x times x over 1. Now x times x times x is x cubed. Divided by 1 doesn't really change anything. So this is just going to be x cubed. Bless you. Okay, number 2. We've got 2 times x times x times x times x over 4 times x. 2 divided by 4, we can reduce that to 1 over 2. Okay, 2 over 4 is the same as 1/2. And then we have 1 pair of x's that we can cancel out. So that would leave me with 3 x's on top, no x's on the bottom. So this is going to be x cubed divided by 2. Now, again, I just want to point out this little shortcut here that we'll really start to take advantage of next time. 5 minus 2 is 3. 4 minus 1 is 3. So there's a connection here between subtracting the exponents and your final answer here. Now, I want you to be careful because if that exponent on the denominator is bigger, subtraction is going to yield a negative number, right? 3 minus 4 is negative 1. So the way that ends up playing out is that instead of the x being in the numerator, it's in the denominator. It's sort of like kind of looking ahead a little bit. So like with this one, we've got 6 over 2 times x times x times x over x times x times x times x. We got 4 of them on the denominator. Six divided by 2 reduces to 3 over 1. And then we've got 3 pairs of x's that will cancel out, leaving us with just a single x in the denominator. So we get 3 divided by x. All right, let's try number 4. 12x to the 5th over 15x to the 3rd. Now, what should we be expecting as far as like our x? What should be the exponent of our final answer here? 2, right? We're subtracting, starting to see that pattern here. So, all right, so we've got 12 over 15. We're going to start with that fraction. And then we've got times x times, we got 5x's in the numerator, 3x's in the denominator. $12 divided by 15, that you can reduce that. And don't stress too much about reducing fractions here. You can use the calculator to reduce fractions for you. Just type in the fraction and hit enter. It'll automatically reduce it for you. But yeah, this will reduce to 4/5. And then we see we've got 3 pairs of x's that'll cancel out. So we do end up with 2 x's, just like we were expecting, right? 5 minus 3 is 2. So we get 4x squared over 5. On number 5, we've got a bunch of stuff happening. So we're definitely going to want to kind of regroup this. And when we expand, we want to bring all the coefficients out to the front, especially looking at that denominator. So our coefficient in the numerator is just 1. Coefficient in the denominator is 9 times 2. I'll just leave it as 9 times 2 for now. But then let's expand out all the variables. We've got x times x, and we got 3 more x's, and then 2 y's. In the denominator, we have 2 x's, and we've got 6 y's. And I'm writing it like this with some space, just because I know I'm going to have to cancel stuff out, and I can only cancel out like terms here. X divided by x is 1, y divided by y is 1, but we can't say that about x over y or y over x. So just putting a little space there to make it a little bit more obvious what's going to cancel out. All right, so 9 times 2 is 18, so I know I've got 1 over 18. And then as far as my x's are concerned, 2 of them cancel out, leaving me with 3 x's on top. And then for the y's, I get 2 of those to cancel out, 2 little pairs here, reduced to 1, leaving me with 4 y's in the bottom. So this is going to equal x cubed over 18 y to the 4th. And that's as far as we're going to go first day back after spring break, okay? Next time, we're going to get into more advanced exponent properties. And then we're really going to start digging into exponential functions. How to identify them, how to write the equations, how to graph them, how to solve them, and all that good stuff. Does anyone have any questions about multiplying and dividing powers?